Lessons probably, right? Starting Monday, maybe. Okay, so let's just have 1 hour, okay? So that you won't be very loaded and you can still relax. Okay, so we will have a 30-minute of math and 30-minute of English. Okay? How's everything, by the way? How's everything? Everything's fine? Everything is under control?
Yeah.
Okay, that's good. So I will share my screen. Okay. Okay, do you see my first slide? Do you see my screen now? Yes, you can. What do you see? Can you read it?
Oh.
Hmm? What happened to your camera? Okay, yes. Okay, yes. So we're gonna learn in detail about properties of real numbers, okay? Properties of real numbers. Okay, why the off is missing there? Let me again. So we're gonna learn in depth the properties of real numbers, so in detail. So hopefully in 30 minutes we can finish everything, okay? And after the class, I will give you a copy of a JPEG or picture of this so that you can review, okay? Kristel, are we set? Are you ready? All right, so let's have, okay? So the first column, this will be the name of the property. The second column is the example. And then the third column will be verbal hints. So it will make you understand more what the property is actually really more about. Okay, so let's have the first property. Okay, can you read the first one, Kristel, what it is? Distributive.
A point.
Yeah, A times, point is times, okay?
B plus C equals A times B plus A times C.
Yeah, you call that a distributive property. It means, how do you understand that? Okay, I will let you see in the board. So this is what it means. So A times B plus C, it means, okay, it means that you're going to multiply A to B, A times B, and also A times C. Okay? A times B plus A times C. That's why it's called distributive, because you're going to distribute A to each. Okay? Kristel, you get it? Okay, an example is like this. Take a look at example. So if you have 3 times 4 plus 5, okay, that means this is 3 times 4 plus 3 times 5. Something like that. Okay, so you multiply the 3 here in the first number and multiply again in the second number. That is with addition. Okay, so what does it mean? It means that multiplication distributes across addition. Okay, so multiplication distributes across addition. Okay, distributive property. You get it, Kristel? You understand?
Yeah.
Okay, let me give you another example. So if you have 2 times 3 plus 4, what is that? How do you do that? 2 times 3 plus 4 equals, you distribute 2. Okay? So that means 2 times 3 plus 2 times 4. Okay? All right, actually, if we are going to give the value, this will be 6 and this will be 8. So 6 plus 8, that will be 14. Actually, the answer is 14 there. Okay? If you see like this, if you see like this, you have to distribute the number across addition. Okay? You understand, Kristel? That is distributive property. Okay? It's very important to actually remember all the properties because you are going to use that all throughout your algebra lessons until the end of the year. Okay, Kristel? Understand? Are you okay? You need some drinks? Okay, let's go to the next one. All right, wait a minute. Okay, what's the next one? Can you read?
Commutative property of addition.
Okay.
B equals B plus A.
Okay, so commutative property of addition. So you just interchange the position of the two numbers added. It will be just exactly the same. Okay? You get it? A plus B is equal to B plus A. For example, let's have an example. 3 plus 4 is equal to 4 plus 3. Because, you know, if you add 3 plus 4, that's 7. If you add 4 plus 3, that's actually 7 also. Right, Kristel? So whether you transpose, it doesn't matter if you transpose or if you move positions when you're adding numbers. It will not affect the value. Okay, it will be just exactly the same. Okay, so that is what does it mean? Commute means to get up and move to a new location or switch places. So you just switch places, but the value is just the same. Okay, it's like you know, for example, you live now in the Mosa subdivision. Kristel lives in the Mosa subdivision now, and then when you transfer to Real, you are just the same Kristel. You did not change at all. All right, so you just change your house, but you are still the same Kristel. That's commutative property of addition. Okay, Kristel, is it easy to understand? Okay, you get it? All right, let's have next one. What is that? Can you read? Commutative
property of multiplication.
All right. So A times?
A
times B
plus A times C
equals
B
times A. All right, so it's exactly the same as the addition, commutative property of addition. It's the same. So when you transpose position in multiplying numbers, it's the same. So A times B is equal to B times A. It will yield the same answers. Okay, so 3 times 4. What is 3 times 4, Kristel? What is 3 times 4?
9.
3 times 12, correct. How about 4 times 3? What is 4 times 3?
12.
12. So you see, you just change position, but still the same value. 12 on the other side, 12 also on the other side. Okay, so you call that commutative property of multiplication. All right, so the same verbal hint. All right, let's go to, okay, again, distributive property is A times B plus C. You distribute A is equal to A times B plus A plus C. All right, now commutative property of addition is A plus B is equal to B plus A. Commutative property of multiplication is A times B is equal to B times A. Okay, so they're almost the same, the commutative property of addition and multiplication. Just the operation is different. Okay, Kristel? Good? Yes, very easy. That's only 3 of the properties. Let's go to the next one. All right, what is this? Can you read?
Associative property of addition.
Mm-hmm. Can you read
Two
the...
A plus B plus C equals A plus B plus C.
Yeah, so that is with addition. So anywhere you put the groupings, it will not affect also the value. Okay, so you see A plus you group B and C together will be just the same if you group A and B added to C. It will be the same. Okay, so example 3 plus 4 plus 5, okay, is equal to 3 plus 4 plus 5. So you just transfer the groupings, but the value is the same. Okay, that's with addition, associative property of addition. All right, so regroup means elements do not physically move. They simply group with a new friend. Okay, so when you regroup yourself to another set of friends, it will be the same value. Okay, Kristel?
Okay.
Yes. All right, let's have next one. So if there is associative property of addition, same as to with, can you read that? Associative.
Associative property of multiplication.
Okay, A times.
A times B times C equals A times B times C.
Yeah, so the same as true with multiplication. You regroup it, the product will be the same. Okay, example, 3 times 4 times 5 equals 3 times 4 times 5. Okay, now let's try. What is 4 times 5, Crystal? What is 4 times 5? Ooh, there is. Oh,
20.
what's his name? What's his name?
Baby girl.
Ah, baby girl. Baby girl. Oh my God, she wants to learn math as well. Okay. 4 times 5, baby girl. What's 4 times 5, Crystal? 4 times 5. What is the value? 20. Yes. Times 3. 20 times 3.
60.
60. All right. So you have 60 on this side. What about 3 times 4? What is 3 times 4?
12.
12. 12 times 5. What is 12 times 5? You can use calculator. You have a calculator? Yeah, so you see the same value. 60 is equal to 60. The same, all right? So that is associative property of multiplication. So when you regroup, it will not change the value, the total value of everything, okay? The same is true with addition. Regrouping will not affect. Okay, now let's have additive identity property. What does it mean by additive identity property? It means that any number you add 0 to any number will be the same number because you are adding nothing. Okay, so 4 plus 0 is equal to 4. 5 plus 0 is equal to 5. It's the same value. When you add 0 to any number, it will be just the same number, of course. Okay, you call that additive identity property. Okay, the value that returns the input unchanged, it will not be changed. because you're only adding nothing at all. Okay, so that is additive property. Now, if you have additive identity property, there's also multiplicative, all right? And that is when you multiply 1 to any number, it will also be the same value, okay? So example, 4 times 1 is equal to 4. So any number for that matter, no matter how small, no matter how big, if you multiply by 1, it will always be the same number, okay? It doesn't change the value at all. So the value that returns the input unchanged, that's what it means, all right? Isn't it easy, Kristel, that property? Very easy, right? Yeah. Now next, you have additive inverse property. What does it mean? Okay, additive inverse property. When you add exactly the opposite of a number will be equal to 0. Okay, so when you add -4 to 4, of course, that will be 0. Okay, because 4 minus 4 is equal to 0. Okay, so any number for that matter. So when you add 5 like this, you add the opposite of it, that will be the same number, that will be 0. Okay, any number you add its opposite will be equal to 0. Isn't it easy, Kristel? Additive inverse property. Okay. Now the value that brings you back to the identity element under addition. All right, that's what the hint is trying to say, but it's not clear though. But it's very easy. Just the opposite of any number added to it will be equal to 0. That's what it means. Okay, Kristel? Good. Are we good?
Yes.
Yes. All right. Let's go to the next property. Okay, what does it mean here? Okay. Can you read, Kristel?
Multiplicative inverse property.
Okay. A
times 1
over A,
where A equals 1
1,
over A.
where A is not equal to 0. Okay, so multiplicative inverse property. As you know, if it is like this, then the denominator is equivalent to 1. Okay, it's understood over 1. Okay, so when the denominator is 1, actually you don't need to write 1 anymore. So you just write A, for example. So what is the multiplicative inverse property is you just multiply the reciprocal of that number. So what is the reciprocal? That is 1 over A. It means the opposite. Okay, so like this, then it will be equal to, of course, it will be equal to 1. Okay, because A times 1 is A. 1 times A is equal to A. So A over A is equal to 1. Something like that. Okay, but the A here should not be equal to 0. You know why? Because if A is equal to 0, then it will be 0 over 0. 0 over 0 is 0, not 1. Okay, Kristel, you get it? All right, let's have an example here. Okay, the example is number 4. 4 times 1 over 4 is equal to 1. Okay, that is multiplicative inverse property. All right, now the value that brings you back to the identity element under multiplication. Okay, not very understandable, but I think you understood already, right, Kristel? You understood? Yes. Let's go to the next property. 0 property of multiplication. What does it mean? So any number you multiply by 0 is equal to 0. Okay, so A times 0, of course, is equal to 0. All right, example, 4 times 0 is equal to 0. Okay, any number for that matter, if you multiply by 0, that will always be equal to 0. Okay, Kristel?
Okay.
Yes. What is this one? 11 times 0? 11 times 0, what is the value?
0.
It's 0. Okay. All right, so 0 times any value is 0. That's what it means here. Okay?
Okay.
Okay, let's go to the next one. Closure. Closure property of addition. Okay. Closure property of addition. A plus B is a real number. Okay. What does it mean? It means that any numbers added, the result is always a real number, of course. Okay? That's closure property of addition. The sum of any two real numbers is a real number. Okay? Kristel, you get it? Now, if you have closure property of addition, there's also closure property of multiplication. So the same thought. The product of any two real numbers is a real number. Okay? So 10 times 5, for example, is equal to 50. It's also a real number. Now, if you have closure property of multiplication, there's also, okay, that's a different property now. All right, now, the last property here is addition property of equality. This one is very crucial because many situations in your algebraic journey, in your algebra class, you will be using it actually. So you really have to understand this, okay? So what does it say? It says there that if A is equal to B, then A plus C is equal to B plus C. So that means, what does it mean? Okay, A is equal to B. That means that when you add a number here and you add the same number here, it will yield the same results. Okay? So you add plus C here will be equal to B plus C. You add the same thing, okay? On both sides, you add plus C and plus C both sides, it will yield the same results. Okay, Kristel? Okay, let's have an example here. Where is that? Where's my cursor? Okay, there you go. So x is equal to 10. Okay, that means that when you add 3, to this side, you add 3 to that side, it will be the same number. So x plus 3 is equal to 10 plus 3. Okay? Something like that. Okay, Kristel, you get it? X plus 3 is equal to 10 plus 3. You add 3 and 3 to both sides. That is addition property of equality. Okay, Kristel? Is it clear?
Yes.
All right, so it says there that adding the same value to both sides of an equation will not change the truth value of the equation, or the true value of the equation. Okay, Kristel, is it clear? Is this one clear? Okay, now let's have next one. Subtraction property of equality, the same. If you add the same value to both sides, will also be the same as subtracting value to both sides, okay? So example, x is equal to 10 is equal to x minus 3 equal to 10 minus 3. Okay, Kristel, is it clear? Now it says there, very good. Now it says there that subtracting the same value from both sides of an equation will not change the truth value of the equation. Okay, now let's have, okay, there's also a multiplication property of equality. So the same, you multiply the same number or the same value to both sides of the equation will also be the same value, all right? So addition, addition, subtraction, and multiplication. And there's also actually division. Okay, so any equation for that matter, when you add the same value, subtract the same value, multiply the same value on both sides, divide the same value on both sides, will be the same truth value of the equation. Okay, Kristel? All right, so that's it. It's pretty easy to remember. The addition property of equality, multiplication property of equality, subtraction property of equality, and division property of equality. Okay? Is it easy to remember and understood? Okay. We'll see. Let's have next one. Okay, it says there, substitution property. This is also very useful in your journey with your algebra, okay? If A is equal to B, then A may be substituted for B or conversely. So you can substitute the value of A to B or the B to A. All right, for example, if you see in this equation, if you look at this, x, all right, if x is equal to 5 and you have an equation, you have an expression x plus y is equal to z. So since x is equal to 5, okay, substitute the value of x with 5 will be the same. So 5, substitute x with 5 plus y is equal to z. Okay, you just change x to 5 because x is equal to 5. Okay, substitution, you call that substitution property. Okay, Kristel, is it clear? I think we have one more slide or one more property in this part. Okay, now what is reflexive? This is very easy. Reflexive or identity property of equality. This is very self-explanatory. All right, means that a real number is always equal to itself. Okay, 1 is equal to 1, 2 is equal to 2, 1,000 is equal to 1,000. 1,000 is not equal to 100. Okay, it's equal to itself. All right, Kristel is equal to Kristel. All right, yeah. Sir Eric is always equal to Sir Eric. It's nobody else. We call that reflexive property of equality. All right. Even twins, they are not equal to one another. Okay, they have some differences. So it's always just yourself equal to yourself. Okay, Kristel? You get it? All right. Let's have last slide. Okay, now, what is this one? Okay, symmetric property of equality. If A is equal to B, then B is equal to A. What does it mean? All right, so you have here an example. 3.5 is equal to 3 and a half. Okay, actually 1 over 2 is 0.5. Okay, 1 over 2, if you're going to divide, 1 divided by 2 is actually 0.5. Okay, so 3.5 is equal to 3 and a half, or then just do the otherwise, just transpose. 3 and a half is equal to 3.5. It's exactly the same. Okay, it's similar to the first property. If you remember the first property. Oh no, the second property rather. Associative. Is it associative? Which property is that? Let's see which other. Let's get back. Which property? Oh, no, it's not the same. Okay, it's different. Somewhere here. No, it's not. Okay, my mistake. All right, a little bit similar to other properties. But that's easy to understand, right, Kristel? Is it easy to understand? The A is equal to B means B is equal to A, all right? Okay, quantities that are equal can be read forward or backward. Okay, all right. So that means, what does it mean? So when you write like this, 5 times 3 is equal to, 3 times 5, something like that. Okay, 5 times 3 is equal to 3 times 5. You can also say 3 times 5 is equal to 5 times 3. This way or that way, it will not change the value. Okay? That's symmetric property of equality. All right. Now let's have the next property. Transitive property of equality. Okay. It's not really confusing, but if you understand, take a little close look, then you have if A is equal to B and B is equal to C, that means A is equal to C. You understand? Or you don't understand? If A is equal to B, B is equal to C, then A is equal to C. You get it? Okay. If A is equal to B, B is equal to C, then A is equal to C. Okay?
Okay.
So all three identities are actually of the same value. So it means A is equal to B, which is actually equal to C. Okay, all of them have the same value. Okay, now example, let's see. Okay, if you see here, if 2A is equal to 10, all right, and then 10 is equal to 4B, then of course 2A is equal to 4B. You get it, Kristel? You understand? If 2A is equal to 10, 10 is equal to 4B, then 2A is equal to 4B. Okay?
Okay.
Yes, it's easy. All right, if two numbers are equal to the same number, then the two numbers are equal to each other. All right, of course. Now let's have law of trichotomy. Exactly one of the following holds. Okay, now what is this law of trichotomy? All right, it means that if A is less than B, it cannot be A equal B, or it cannot be A greater than B. It's just one of the three. It's always, one is only true among the three. You understand? So if A is less than B, then A, it cannot be equal to B and cannot be greater than B. Or if A is equal to B, it cannot be less than or it cannot be greater than. Only one value is true at a time. Okay, Kristel?
Okay.
It's just like if you have three friends. Can you give me two names of your friends?
Denise and
De
Kimberly.
Denise and
Kimberly.
Kimberly. All right. So Kristel, Denise, and Kimberly. Denise, am I right? Denise?
Denise.
Denise.
V. V. Then
Venice? Oh, Venice. All right. Kristel, Venice, and Kimberly. Means that all three of you are not the same. Only one of you is Kristel. Venice can never be Kristel. Kimberly can never be Kristel. The same is true with Venice. Venice can never be Kristel and can never be Kimberly. Same as true with Kimberly. Kimberly can never be Venice and can never be Kristel. Okay, so only one is true among the three. You get it, Kristel? As simple as that. Okay? You get it? All right, so that's it. We're done with properties of real numbers. I hope you understood everything. And this is just too much to handle. All right. So that's it for the properties of real number. I will give you the slides, pictures of each slides, and then you again go through and try to, familiarize yourself because you need them along the way. Okay, Kristel? But don't worry,
okay.
in your algebra journey, you're always with me, all right? So I can always guide you. All right, Kristel, so let's have English this time. Okay. Any question with the real properties of number? Okay, so far I think that's the complete properties of real numbers that you should remember. All right. Question? No question? Okay,
No.
I will stop sharing the screen I have and we'll go to present simple tense with English. All right. So let's study tenses one by one. But this time, just for 30 minutes, let's have present simple. All right. I will erase what's written in the whiteboard. Okay. Can you see my whiteboard clearly, Kristel? Is it?
Yes.
Yes, you can. All right. Don't worry, this is pretty easy. Present simple. Okay, present simple. Now, what are the forms of present simple? The forms, there are two forms. You have the S form, means there is S in the verb, and then you have the base form, okay? If you remember the subject-verb agreement, if the subject is singular, the verb is also singular. Do you remember that? If the subject is plural, the verb is also plural. It means that if the subject is singular, you have to use the S form. And then if the subject is plural, you have to use the base form. It means without the S. Okay? So that's the form for present simple. Okay, now let's have positive sentence first. Positive sentence. All right. Now, if your subject is singular, you're going to use S form. So let's see. He, for example, he goes to school. All right. Is it correct? Is it goes or go?
Correct.
It's correct. All right. It's grammatical. It's grammatical, right? Okay. Now, if your subject is plural, they, what happens? Are you going to use go or goes?
Go.
Go. All right. So, like that. Okay. So, he goes to school, goes because your subject is singular. And then they go to school. You use go because your subject is plural. All right, Kristel? Okay? All right, pretty easy, right? So don't forget, any singular subject use the S form of the verb. Any plural subject use the base form of the verb without the S. All right? Now, how about if your subject is I? Are you going to use go or goes? I, is it I go or I goes?
Go.
Hmm?
Go.
Go. Did I hear go? Did you say go?
Yes.
All right. Now, why you use go here when the I is actually just one person? Why do you think?
Go.
Because I is actually a special case, okay? It doesn't
I go.
follow. It is a special case. It doesn't follow the rule, okay? Because I is special, okay? I go to school, not I goes to school. Okay, that's for positive statements. Okay, Kristel, is it clear?
Yes.
Clear, all right. Now, let's do negative statement this time. Okay. Negative statement. It means there is the word not. Okay, now if your subject is singular, like he, she, it, then you're going to use doesn't. Okay? Doesn't. All right, and then main verb is base form. It should be doesn't go, not doesn't goes, okay? It should be he doesn't go to school. All right, Kristel, you get it? Yes. Now, how about if your subject is plural? Then you are going to use don't, okay? And the same, your verb is, main verb is also in the base form. So they don't go to school. Okay, you get it? Yes. All right. And then the same is true with I. You're going to use don't as well. I don't go to school. Okay, I is a special case as well. Is it easy? Subject is singular, use doesn't. The main verb is base form. Subject is plural, the main verb is also base form. Okay, Kristel? Quite easy. Okay, now let's do question form. Okay. Now, how do we do with a question? Okay, for question, you are going to use does if your subject is singular. All right. Oh, your dog changed. A while ago you have baby girl. Now you have, who's this? Kendall?
Tally.
Tali. The chubby Tali. Tali is learning English this time. Okay. Where is it? Where's baby girl? Is there? Baby girl is there. Okay. All right. They're learning English. All right. Now, in making questions, you're going to use does and do. Okay. So does, if your subject is singular or plural? Does. What do you think? Singular or plural subject?
Singular.
Yes, singular subject. Okay, example he. Example, does he go to school? Question mark. Okay, so does he go? Does, subject, and then base form of the verb. Okay, now if your subject is plural, of course, you're going to use do. So example, do they go to school? Okay, like this, Kristel. Do they go to school? Always you have the base form of the verb. Good. If your subject is I, how about if your subject is I? What are you going to use, Kristel, in question? Does or do? Subject is I. What are you going to use? Does or do?
Do.
Do. Okay. Do because I is special. So do I go to school, for example? All right. That is how you make question with present simple. Okay, now let's have how to make short answers with present simple. Okay, for short answers, if your question is does he go to school, your yes answer will be, what will be the yes answer? Does he go to school? How do you answer that with yes?
Yes, he does.
All right, very good. How about if the answer is no? No?
No.
No? Yeah.
When
No, he doesn't.
oh,
Okay, no, he doesn't. How about if your question is, do they go to school? What is the yes answer? Short answer. Do they go to school? Yes.
yes, they do.
How about the no? No.
No, they doesn't.
No, they don't.
No,
Okay. No, they don't. All right. For plural, no, they don't. For singular, yeah, no, no, he doesn't. If your subject is he. All right. Okay. Same goes with I subject. So if the perspective is I, then the answer will be no. No, sorry, yes, yes, you do, or no, you don't. Something like that. Okay, Kristel? All right. Now, why do we use present simple? We use present simple, okay, two things. All right. We use present simple when we talk about general truth, okay? Sorry. One is general truth, okay? When you want to state something that is a general truth, then you use the present simple. For example, you say the sun rises in the east. It is general truth. The sun, singular subject, so rises as form of the verb, okay? The sun rises in the east. Same as true, the sun sets, okay, with S, in the west. This is general truth, okay? So that's one use of present simple. Another use of present simple is, do you understand this point here? General truth. So anything true, you want to state it, use present simple. Okay, very good. Now, another one is when you want to state a habitual action. Okay, it means that something that you do regularly. For example, Kristel goes cycling every afternoon. Okay, you are stating a habitual action. It means like a habit, you know, it means you are doing it regularly. And another example, Kristel goes to bed at 10, for example. Okay, or Kristel brushes her teeth every after meal. That's also a habitual action. Kristel takes a shower every day. That is a habitual action. Okay? What are other habits that you do, Kristel? Do you know the word habit? Habit? Yes. Can you tell me more about your habits? Do you have any habits? I heard that you, yes. What? You have a habit? Any habits that you can tell me?
So this one.
What is it?
Making
Cell
a
phone?
design.
You design? Oh,
Yeah.
really? You do the design yourself?
Yeah, I painted. This is paper. See?
Oh, that's only paper. How
Yeah.
did you do that?
Uh,
So you design.
yeah, I painted.
Really?
I have like this that I painted.
Oh, very nice.
And
You
then,
did it yourself.
yeah.
You can make money out of that. You design things, you know? Oh, yes. You can design for your interior in your house, you know? That's good. What are other habits that you do? I think you keep a diary, right? Every day. Do you still keep a diary? Not anymore.
Sometimes I forget.
Sometimes you
Right?
forget. But you do keep a diary, right? Keep a diary.
Yeah.
Who feeds your dog? Do you feed them?
Yeah.
You do. Okay, that's also another habit. You
I feel it was here.
okay.
Yeah.
All
That
right. Yes. And I think you also do gardening. Do you do gardening in your house? You
Sometimes I help with my mom.
Yes. You plant vegetables, right? In your garden?
Yes,
Yes.
we have
You have a lot to
vegetable.
Yeah. What vegetables do you have in your garden?
Uh, Pechay.
Oh, it's hard to grow. Pechay is really hard to grow.
Yeah.
Yeah. Pechay, what
I
else?
see vegetables there.
You have alugbati,
Yeah.
yeah, alugbati, right? What else? You have malunggay. I saw
Yes.
malunggay. That's also hard to grow, actually.
Even
Uh,
it's not a vegetable, but we have a lemon grass.
lemongrass. You have lemongrass, I think.
No.
What?
And lemons.
Lemons, yeah. Oh, that's good. Do you have calamansi tree? Do you have?
No.
No, you don't have. What else do you
Mm,
have there? And I saw you have a lot, your house has a lot of flowers as well, right?
yeah.
Yeah,
Yes. Mommy loves flowers.
loves flowers, yes. Your mom loves planting flowers and vegetables around. Okay, that's good actually. So that's a habit also. So when you state a habit, you use the present simple. Okay? When you say general truth, you use present simple. Okay? You get it, Kristel? Is everything
Yes.
clear about present simple?
Yes.
Everything's clear. Tomorrow I'm gonna check. I will have a little quiz about present simple and properties of real numbers, okay, before we start our new lesson tomorrow. Okay, so for the time being within this week, we just have 1 hour, 30 minutes English, 30 minutes math, okay? But when your class starts, we might have a longer time because we need to do your assignments and activities that you need to do, okay? Kristel?
Okay.
All right. Don't forget when you have already something in your classes, screenshots, okay? Maybe on Monday, right? Maybe. Okay, Kristel, if you don't have any question? Not
No.
at all? Okay. What time is it there, by the way? It's 9,
9, 10.
it's 9:10, right? Okay, Kristel, I'll see you tomorrow. If you don't have
Okay.
any, all right. Thank you very
Yeah.
much. You were good
Thank you.
today. Okay. I will send you the picture of the properties of real numbers, okay?
Okay.
And please study them. And you did not send me your recording yesterday.
Yes.
Please
Okay.
send today. Can you send it today? Okay? All right, I'll be waiting. Okay, Crystal, you can hang up if you don't have any questions. We got this.
You got this.
And send me your recording, okay? For yesterday.
Okay.
All right. Thanks,
Thank
Crystal.
you.
See you
Bye.
tomorrow. Yes, you're welcome. Bye.